Hello, everyone. I'm Gary Berman from DevOps.com and the host of the Cyber Hero Adventures Show. It's a pleasure to welcome you to another great DevOps.com webinar. Today, we're going to learn about why managing messaging connectivity across applications and data efficiently is a critical component of any hybrid cloud strategy. But before we get to today's presentation, let's go over a few housekeeping items. As you see, we use the GoToWebinar system, so for many of you, you'll see the control panel. Please take a moment to click on the questions icon and the little downward arrow. This webinar is designed to be highly interactive with our great speaker. So we welcome your questions, comments, and suggestions in real time, and we'll get to as many as we can as possible. If for some reason we can't get to your question, we'll make sure to email the replies to you shortly. This webinar is being recorded, and the slides will be available to you on demand at devops.com in just a couple of hours. Additionally, we have a special giveaway. 4 $100 Amazon gift cards at the end of today's webinar. So stay tuned to see if you are one of today's lucky winners. And now, a special thank you to our sponsor for today's webinar. Lior Nabat is KubeMQ's technology leader and product architect. Today, we're going to begin with an instant poll question to understand where you are on your journey. So please answer the question. My Kubernetes phase is, and you can select one of the following: just started to learn, evaluation, migration project, or deployment. We'll keep this poll open for about 30 seconds or so, so please just click on your response. Of course, there are no right answers, whatever your particular journey is. Thanks in advance for sharing them, and we'll be sharing the poll results with our audience before Lior takes it away. Okay, so about half of you are just starting to learn, and 16% in the evaluation phase, and then 12% in migration, and about a quarter of you are involved in deployment. Lior, take it away.
Hello everyone, my name is Lior Nabat. I'm coming from KubeMQ. Today we're going to do something that is also challenging for me to actually do and show you how we connect clusters, Kubernetes clusters, environments, show you microservices live running, and many demos that as much as we can from time perspective. So again, thank you very much for this. Together with me is also Gil and Oz from our team, and there's some questions during this webinar we'll be able to answer. What we're going to do is this. I'm going to a little bit talk about KubeMQ. What is it? Why you need it? What are the components that we're going to use? What are the scenarios, the use cases, how we can connect between services, microservices, clusters, and also we're going to do a demo and real live demo of how we build topologies of backends. And I'm sure that it will be interesting for you. I will try to elaborate as much as I can and try to find the balance between time and how to show the demos. Okay, so we're going to start. I think we can start by what is KubeMQ. Now, KubeMQ is a platform. Means that this is a set of components that you deploy in a Kubernetes cluster that is give you a Kubernetes native enterprise-grade message broker that give you the ability to connect between services, doing hybrid cloud messaging connectivity, migration. This is very hot topic on many backends that, for example, you have a legacy system that you would like to migrate to a Kubernetes type of messaging or Kubernetes type of service. And what I mean is that what I mean Kubernetes native is it was designed to run in Kubernetes, means that it's deployed with operator. For example, and I will show here also a live demo with an OpenShift cluster that I deployed before. And in OpenShift, you have the ability of your operator lifecycle, and you can easily deploy this with the operator, and also with many tools that also I'm going to show you a tool that is a CLI tool that we are using. This is like at our control center. It's very small, blazing fast, written in Go. It's a lightweight Docker container, and the main cluster, the Kubernetes cluster, is actually a stateful set. Simple stateful set that you can use with persistent volume or without persistent volume. And if you have more time on it, I will be able to explain the difference between them. Another very unique feature that KubeMQ has is that you don't need to configure anything. And I will show you in a minute that actually I'm going to deploy KubeMQ almost with zero configuration. This means that you don't need to create queues, exchanges, do some partitions, nothing. It means that once you deploy it, you connect to it, and then it's doing all the work by itself. The main interface to KubeMQ is a gRPC interface, and this is also going along with Kubernetes. Kubernetes is mainly gRPC connectivity, and I think one of the best thing of gRPC is the ability to not only doing like an RPC calls, but also stream. Ability to stream data, and this is something that is very unique to KubeMQ, that because you can be able to connect and use KubeMQ in streaming mode, means that you don't need to open or close connection all the time. Another good features is from the Kubernetes native point of view is the integrated metrics and tracing built in KubeMQ, means that you will be able to we're exporting Prometheus and tracing information to the Kubernetes cluster. This gives you some kind of observability capabilities. If I will move a little bit forward, I would like to discuss about what, when we talk about messaging platform, KubeMQ support 5 messaging patterns that actually divided in 3 families. The first family is the queue family. This is only one messaging pattern in the queue is a queue. This is, if you're familiar with Amazon SQS, this is very similar to Amazon SQS, almost even the same functions. It's a FIFO-based queue. It's ordered, and the ordered is preserved. Support many things that actually helps you to work in this asynchronous type of messaging, like message expiration, delay, delivery. Dead letter queues very powerful in situations that you need to handle poison message, for example. Long polling means that you can connect to KubeMQ and wait for amount of time that you would like to see if you have messages. Very unique feature, what we call the peak messaging, means that you can look into the queue, get the data, but actually not removing the messages from the queue. This is very powerful way to see, okay, what I have in the queue and how I can even know how to handle it. You can, of course, removing like all the messages. I can work what we call in transaction mode with message visibility means that I can connect to KubeMQ, take a message, and tell KubeMQ, okay, hold this message for 60 seconds. I'm handling it now, and later on I will tell you what I'm going to do with this message. If I would like to acknowledge it, if I would like to reject it, or do something else with this message. Push and push mode means that it's more, you can take messages from the KubeMQ, or KubeMQ will push you messages. This is for the Q family. The second family, the PubSub family, it has two messaging patterns. The first one, what we call it events. This is a real-time, in-memory, very fast PubSub messaging system. And we have persistent PubSub, what we call event store. And here we can see the first when you want to do persistent with KubeMQ or not. The persistence in the PubSub means that you can do some like offsetting of messages if you would like to get a message from the last 5 minutes or from specific timestamp. And a nice thing is that you can have some kind of what we call load balancing and consumer groups and wildcard partitions. Events are very powerful way to send a lot of data to many subscribers at the same time. And it's and I will show you in the demo one example of it. If we discuss about the Q family and the PubSub family, both of them are what we call it an asynchronous messaging patterns. The RPC is a synchronous one, means that it's like a request and reply, very powerful in scenarios like microservices. You have a database that you would like to say a query to it, and you're waiting for a specific time to get an answer. Also support consumer groups, load balancing, and very powerful way how you can set a time for how long you're going to wait. And if there is no answer, you get an error with a timer. So the RPC is a good way to connect or communicate with services that you send and waiting for receive information. Okay, so after we discussed and I explained the messaging patterns, so we can now group everything together to what we call KubeMQ platform components. I'm going to show you about 4 components, main components that you're using that to build any kind of architecture you have in mind, and we will play in demo and show you what I mean on this one. So the first, of course, the component, this is what explained showed before. This is a cluster. With all the messaging patterns, this is the heart of the system. We have 3 components, what we call them connectors. Connectors are also a Docker container, mainly as a deployment one, that has specific connectivity functions. So we are dividing them to 3 types of connectors. One is what we call KubeMQ Targets. What we mean in targets means that this is like we integrate a third-party system that you would like to connect your cluster, your queue. One of the challenges of working with a message broker is how I connect several external services like caching, database, other messaging, any kind of external services that you would like to connect. And KubeMQ Targets give you this this capability. Currently, I will show you in a minute, we support more than 60 type of integration connectors, and I will show some of them later on. The second connector, what we call KubeMQ Sources, this is actually the other side of the targets. If the target's main idea is to communicate information from the KubeMQ cluster outside to external system, the source is doing the opposite way, means that it's ingesting data to the to KubeMQ. This is very powerful when you like to do like a migration, means that you would like to connect external messaging system like MQP type or RabbitMQ, Kafka, even an HTTP. And I will show in a demo how a KubeMQ source act like an API gateway, means that you can connect a legacy system with REST interface to KubeMQ with this component KubeMQ sources. So targets and sources actually going together. One is to connect outside, and the second one to bring data inside the KubeMQ cluster. The third and very, I think, a very interesting connector, what we call bridges. Bridges helps us to connect between KubeMQ cluster. And I will discuss a little bit this later on, but the main idea behind bridges is the ability to connect several KubeMQ cluster, no matter what they are in the same Kubernetes cluster, even in the same namespace, or even outside of your environment. If you are running on-prem and you would like to run on a cloud, or if you would like to connect between clouds, and I will show in a demo how we're going to do it, and how powerful is it. So I believe that the main power of the whole KubeMQ platform and components is the ability to build a hybrid cloud environment. Means that you can run services in any environment, on-prem, on clouds, on the edge, and you are now able to use KubeMQ to connect between all your environments and be able to consume any service from anywhere. And in the demo, I will show you a glimpse of how easy it is to do it and how it works. As I said before, the KubeMQ targets is, from one hand, what we call sources and targets. Means that from one hand, the KubeMQ targets, this is a component that's listening to a KubeMQ cluster resource like queries, commands, events, and then connect to an integration outside. This is what we call a binding. This is an open source project. You can have a look on the GitHub page. You can see that this is KubeMQ Hub, KubeMQ Targets, and then you can see all the integrations that we are supporting. This is very few supporting. It's actually separate between 4 families. One is what we call a standalone system, like databases and cache that you are installing no matter where you are, and also what we call a cloud-based services. And we support almost all the services in all the clouds, even in in GCP, in Amazon AWS, and even in Azure. You can check out the updated targets in the GitHub page. You will see a very long list of all the integrations that we are supporting. Now, the source is actually the other side of it, means that we can connect, as I said before, interfaces mainly from messaging type. This is mainly for migration, and I hope I have enough time today to show you some kind of one migration with RabbitMQ. This is a part of the plan. As I said before, KubeMQ Bridges is very unique way that you can connect now between several clusters. And one example is what we call a bridging. Means that, for example, I have 4 clusters, and I would like now to bring them together and be able to access services, for example, a query service, a query message patterns, that if, for example, a service in cluster that connect to a cluster A would like to get a service from, for example, a cache system like Redis in that actually connecting to cluster B. So the KubeMQ Bridges is the way to connect and show how to bridge them. And I think you will see in the demo a demonstration exactly for this one. Another very powerful way is what we call replication. Let's assume that you have a system or service that is connecting to cluster A, and now cluster A, and now you would like to replicate events to other clusters. It can be in the same Kubernetes cluster, or it can be in different environment on the cloud, on the edge, or even vice versa. So replication gives you the ability to replicate messages in any message pattern, events, event store, RPCs, and etc. Another one is what we call aggregation. This is actually the other side of it, means that you can now aggregate data from several clusters, again, no matter what they are and where they are located, and to a cluster and in that you are now ingesting the data. This is very powerful way, for example, in the IoT type of application, that now you have a lot of edge components that, and in edge environment, that you can run KubeMQ cluster on an edge device, because it's very small one, so it's very easy to deploy a cluster there. And then now you can be able to aggregate a lot of data from all the clusters, all the edge cluster to a single cluster. And the last one is what we call a transform. Means that in transform you now be able to actually play with the topology. You can aggregate, for example, events to a cluster D, and then convert this message to be a queue messages. An example for this one can be, for example, you are ingesting a lot of data, but you would like to handle them in order way in different clusters, and then you're going to use a queue type of messaging. So transformation is very good way to do it. And again, the demo will, I'm not sure if we have time for this, but if yes, I will show you an example for this one. So this is actually an introduction to what KubeMQ is. And maybe we can, this is the time that we'd like to do a pause before we start with the demo, or I can continue. or answer questions?
Yes, we're going to do a poll now. This is incredibly interesting. Wow, thank you so much for what you're sharing so far. We'll be launching the poll in just a moment here. The question for the attendees to answer, please, today, what I use for messaging is, and you can select any one of the following. I don't use MQ. I use it without Kubernetes. I use MQ with Kubernetes, or I look for Kubernetes native MQ. So, of course, all answers are great. Just put in where you best think describes where you're at. And just as a reminder, please feel free to use the question tab to ask Lior any questions. Sometimes we do them during the presentation, and sometimes we do them after. So now we'll have the results of the poll. And the results are that I don't use MQ, about half. Another 28% use it without Kubernetes, 12% with Kubernetes, and 8% I look for Kubernetes native MQ. Take it away, Lior.
Okay. I see a couple of questions there in the chat. Maybe I will try to give a very quick answer. One of the question is, what is the relationship between KubeMQ and Kafka? It are not relations. Means that KubeMQ is actually what you have in Kafka. Everything you have in Kafka, you have in KubeMQ and even more. Kafka is more what we call the old school way to use messaging. KubeMQ is a Kubernetes solution. Means that everything what you have in Kafka, you have there. So the relationship is we're actually doing a lot of we see a lot of people that actually converting using KubeMQ to do migration from Kafka type to Kubernetes environment. So so if I now go to our demo, is that second, please. What we're going to do, we're going to build together couple topologies, and we're going to do it in gradual way. We will start what we call a typical microservices architecture. In this demo, what we're going to do, I prepared 3 services: Redis for caching, Postgres for database, and Elasticsearch for logging or whatever we want. And the demo here is to show you 2 things. The first one, how an application, a simple one, that is for one and connected directly to KubeMQ cluster with an SDK, with any kind of connectivity that you can use, is utilizing this the services, the Redis service, the database service, and the Elasticsearch service. Another thing we're going to do is we're going to add what we call an API gateway. Now, what is the advantage of it? Let's assume that you have a service, an old service that is supporting only HTTP calls, post, get, and you would like to give them an access also to the same functions that you have in Redis, Postgres, and Elastic. KubeMQ Sources will give these capabilities and be able to convert the request on the HTTP side to actual request that the targets will understand and give the service. Later on, what we're going to do is part of what you're going to see here. After we will deploy the microservices, and as you saw before, and again, I hope I will have enough time, we're going to extend this cluster. Means that we're going to build, or we're going to connect an application. In our case, will run on OpenShift on a cloud-based solution. And together with the bridge, we will give to the service, the cloud application, the same access to Redis, Postgres, and Elasticsearch together with the bridge. And I'm not sure that we're going to have build together enough time to build an edge application, but if yes, we'll be able to show you also another way how to connect MQTT type of connectivity with the sources together to a bridges. But another interesting thing that we'd like to do is to do something like a migration. Means that in migration, I'm going to have two services. One is directly connected to a RabbitMQ that I previously installed, and another service that's actually running on a cluster, Kubernetes cluster, and I will do a ping pong between them. Means that on one hand, we send a message to RabbitMQ, and a component KubeMQ Sources will take this message, send it to a KubeMQ cluster. The migrated service will take this data and send back a POM message, to the targets, and then back to RabbitMQ, and we can do ping pong, ping pong. And this is very nice, nice demo to see how it going to works. Okay, so let's start, and may the God be with us on the demo. So first of all, we're going to start and build a microservices one. Okay, so I will try to switch my what I see. Do you see my screen? Yeah. Okay.
We can see your screen, but we don't see the video here. So if you can fix it, try and fix it.
What do you want to see?
We see your screen, your share screen, but we cannot see the video. So your video.
Okay.
See if you can fix it. If not, we can see the demo anyway. So it's fine.
Okay, so maybe the but the screen with the terminal you see, yes?
Yeah, we can see the demo.
Good. So first of all, before we start, we'd like to introduce you to what we call the very powerful tool. That this is a CLI tool, what we call the control center, that use KubeMQ. KubeMQ CTL give us the ability to manage and actually do all the configurations that you have in mind for building and testing, helping to develop with this tool. I can spend hours to show you demos with the KubeMQ CTL, but this is the main tool to work together. So first of all, what we're going to do is run KubeMQ. Or again, if you see something that is interesting or something that is not, I'm not paying attention from during the demo, please stop me, and then and I will be able to answer. So the first thing I'm going to do KubeMQ CTL M is manage, and this is like a control center to manage many components, all the components in KubeMQ. Now, I installed already, I have a, what we call the Kind. Kind is a very quick way to deploy a Kubernetes cluster. And I'm currently going to be able to connect to Kind in the Kind context. And I have other contexts that later on I will switch, but this is currently the main one. I'm going to start manage by clusters. So the first thing I can do, first of all, if I have already cluster that running, yes, I have already one KubeMQ cluster that it's already running. You can see, yes, this is what we call KubeMQ cluster that already in the system. I will delete it. That just so that I'm starting from scratch. I can see that there is no clusters. And what I'm going to do is I'm going to deploy Kubernetes cluster, and I can see how fast and how easy it is to add a KubeMQ cluster. That it's actually very easy to do. First of all, I will add a normal one KubeMQ cluster. I will put it in a namespace called KubeMQ. How many replicas I have, and again, you need at least 3 to form a cluster. This is a stateful set, and then it can ask you many. It can tell you 2 options. One, if you'd like to deploy with the default one, or if you want to select the configurations. If I have time later on, I will be able to show you what we can do with all the configuration. But we will go with default one, means that now we can show and see that to deploy and running one. So let's see if it's running. Yes, I have already. Again, because this is I think this is because this is the screens trying to be bigger. Did the size of the text is fine?
Yeah, I can see it very well.
Okay, I will try even to little bit decrease it in order that you will have more data on it. So currently we have a KubeMQ cluster. The next thing I'm going to do is what I call adding integrations. As I showed you before, I have 3 external services: Redis, Postgres, and Elastic. And what I'm going to do now is quickly show you how I'm going to do it. And before I'm going to do it, you can see I would like to show you something very interesting, is what we call the integration catalog. It means that you can browse through this, what kind of targets we have, what kind of sources, and you can see very long list of almost any kind of target available in our system. Also, the source one, you can see which one we are going to support. We're going to use today HTTP and RabbitMQ, but mainly this is the catalog of integration that we're going to use. So let's start by adding integration to our system. The first one, we're going to select the cluster that we want, and I would like to add 3 target integration, one for Redis, one to Postgres, and the third one for Elastic. So I will start with the first one. I will call it Redis. Then I will choose Redis. I can even, put what starting with Redis and give you what will be all the possibilities. You can see that there is a GCP one. Also, if you want to use, but I'm going to use the native one, cache Redis. And I already prepared from the beginning. I prepared the data and the URL, but in order not to trying to look around. But this is the Redis URL. And now we ask you, okay, to what kind of source, or to which one, what kind of service, or what kind of message path you will have to listen in order to forward your request to Redis. And again, what we're going to do with Redis is we're going to do the three main functions: set, get, and delete. Set a key, get a key, and then delete a key. So these patterns is, this request is more a query one. So I'm going to choose a query. And again, it will ask me to what kind of endpoint we're going to use to connect. And this is the cluster. And what will be the channel, the topic that we're going to use here, automatically give me an option what called query to Redis. And again, here, if I want to configure more things, I can do. If not, automatically give me this one. Now, we have something very interesting, what we call middleware. We can give you. Let's assume that we can have logging, retry mechanism, rate limiting. This is a middleware that you can attach to every integration separately and give you more fine grain on your integration control. But currently now, in order to run through this demo, I will not do any middleware, but it give you, okay, this is the configuration. I have a Redis that I'm listening to KubeMQ query in the channel query.redis, and forward all the requests to a Redis in this port. If we like to say this integration, I say yes, and up and running. The system is now building this configuration, bring up containers, and I will show you in a minute more what I mean. But in the meantime, in order to go forward with the demo, I will add the Postgres one. I will like Postgres, and again, I will take a connection string that I have. And then the same I will do with another query. Again, in Postgres, what we're going to show you is two things. What we call transaction, we're going to create a table, we're going to insert data to a table, and we're going to do query with the table. I will show you in a minute how we're going to do it. But this is what we're doing with Postgres. Again, query, Postgres, and the same here, no middleware, run. And let's add another one, what we call Elastic. In Elastic, we're going to play with indexes. We're going to remove index, add index, set keys to it, set documents to index. You will see in a minute how it works. I will call it Elastic. And again, I will search for Elastic, towards Elasticsearch, and then again, we'll copy a ready-made URL, set the default, and then I will like a query. That's it. I'm done. What we have done, we add three integration, and one way to see is let's log into the containers that we are just now creating. So KubeMQ CTL get con logs. He will now show me which kind of connectors are already up and running, and we see that we have one that we already configured through the integration process, and I can see that it's running. And I can see even, let's see, we said we have three, okay, see the Redis one, the Elastic one, and the Postgres one are initialized correctly. So we are good to go. So, okay, so how I'm going to test it? So in order to test it, I built an application. if we switch back to the screen, I built the deploy application that will now going to send to Redis set, get, delete keys, going to simulate to Postgres ability to create a table, insert data to a table, and retrieve data from a table in a query. In Elasticsearch, we're going to check if index is going to be is existed. If yes, we're going to delete it. We're going to recreate it, and then we do the same what we did with Redis: set, get, and delete. Now, I will switch back to this one. Okay, and before I'm going to do it again, in order to be able to quickly able to work on what I've done, what I'm going to do in separate window, I'm going to do port forwarding in order to connect, be able to connect to our service, the connectivity directly to KubeMQ. This is only from connectivity point of view. This is the application will use the local host 50,000, and I'm port forwarding directly to KubeMQ cluster to the service in order to be able to send that to it. And if I can run it, you can see that I can run it. Sorry. Okay, so what we saw here are three sections. The first one, we are sending the Redis request directly. We are set request for a or random key with some data, getting back response that I have okay, and execute a get or do a delete and then go back. This is for the Redis. For Postgres, we are do some kind of transaction, do request of a query and get back data. And in Elastic, we doing log index. If it's not, we are creating it and then do the same set, get, and delete. Okay. So just to show you that I'm not, just to show you that it's not pre-ready. So we can do something like, let's try to remove one of the integration, KubeMQ, CTL, manager, and then let's try to delete the Redis one, and then we create it again. I just deleted it. Again, if I would like to see that it was deleted, I can run the logs. I can see that now I have, no, it's not the one. I hope it was what I did. Let's see if it's still running. Yeah, no, we didn't delete it correctly. Okay, let's see. No, I didn't do it. Okay, never mind. Let's move forward. KubeMQ, CTN. Let's now try to show the second thing is if you remember, I want to do, so I'm trying to move to, okay, in the microservices here is we show how we connect the application directly to Redis, Postgres, and Elastic. And what I'm going to do, I'm going to show you how do we build a source to the cluster and give the ability to external services that using REST API, also the same function that I did with Redis, Postgres, and Elastic. Okay, so I will do it again. Okay, and now I'm going to add 3 integration, but a source one. The first one is going to be, we call it again, we can call it Redis. Now I'm going to use an HTTP in post, and now the URL will be the URL of the container of KubeMQ Sources /Redis. And all the data
Lior, forgive the interruption. I don't think the audience is seeing that. We're still seeing your microservices slide. But also, we have so many great questions, and people are incredibly interested in what you have to say. Would you like to try to address some of the questions, or would you prefer to just continue because we're almost out of time?
I will try to. I will complete the what I'm doing now with the. Okay, never mind. Let's do some of the questions and see how long we have, and then we see how we can run. Okay, I have a couple quick questions. Yeah, we can share the KubeMQ demo repository, no problem. We have a dashboard, a web one that you can use. This is mainly based, again, this is Kubernetes that we are using the Kubernetes services. So it's a Prometheus with Grafana. If there is a support for transaction in addition to at least one, yes, you can have at least one, once, at most one, and exactly one. So also transaction support in the queue. Let's see more questions that I can.
Well, I had a question. You know, what volume of messages can KubeMQ support?
Okay, so this is one of the great thing of KubeMQ. Since this is very small and written in Go, it can handle millions of messaging per second. This is depend on the message patterns that you're going to use. But we tested, and it's like a linear way of. You give more resource, more CPU memory, you can get more and more. But it can, in our environments, you can even use millions of messages per second, depend on the size. This is not this is a very powerful way.
And you know, I'm sure our audience would love it if you could share a use case, you know, from production implementation.
Yes, I think one of we have one of the key things of what KubeMQ is in the financial systems that KubeMQ today drive billions of messages per day in banks and brokers, mainly in Japan, that using KubeMQ as a backbone for messaging between all the services. If it's a notification services, if it's a core services, if it is transaction services, KubeMQ is the backbone for this system. It's run almost 3.5 years on those systems already. This is a battle-tested platform that's running for a couple years and used in production in financial systems.
And you know, so in your opinion, why should someone implement the message queue inside the K8s cluster, you know, rather than outside? What are the strengths and weaknesses?
Oh, this is the great question. Okay, this is bring me to one of the key elements that are very powerful with KubeMQ. When you put a messaging system outside of the cluster, it means that you actually replicate every message. Every message needs to go out and get back in. So it's a problem, also a very big security problem. One of the good and I think one of the advantage of using Kubernetes is the ability to run anywhere you would like to deploy quickly. So for example, if you're running on the edge, so how are you going to deploy in I don't know, in very small, in ARM7 type edge or ARM9 type edge cluster? So you can install Kafka there. You can install RabbitMQ there. So when you are using internal messaging in Kubernetes, you give you all the flexibility to use even what we call micro clusters of Kubernetes, and you can deploy anywhere, and you can use these systems, use this cluster to connect to any system, and not going out from the cluster. For example, if you are using a service mesh, so how are you going to handle all the security certificate if your messaging platform is outside of the cluster? It's impossible. So this is why and where KubeMQ shine on why to use messaging inside Kubernetes platform.
Wow, thanks for that. We have our final poll question that we're going to put up now. And remember, there are no right or wrong answers. So whatever's the case for you. The question is, KubeMQ for me is, and you can respond for future review, it could be great for Kubernetes, enables migration, supports hybrid cloud. I use KubeMQ now. So please just select your answers. And we thank you all so much for your great feedback. This is incredibly valuable and useful to our team to formulate future plans and to incorporate your feedback to ensure that this is our solution is as valuable to you as possible. So the results are just over half said for future review, about a third great for Kubernetes, 6% enables migration, 12% supports hybrid cloud, and no one is using KubeMQ right now. Did you want to comment about that, Lior? And then we're just going to wrap up. We're right at the top of the hour.
Actually, yes. I already showed about only 10% from a demo. I think that if the people are going to join KubeCon in 2 weeks from now, you will be able to visit our booth in KubeCon, the virtual event, and you'll be able to see all these demos even more. And I would like also to quickly address 2 quick questions about. I see that in the question side, if we support ARM, the answer is yes. If you have Kubernetes there and Docker, you get also KubeMQ there. And about the bridge, and I'm sorry that I was not able to show how easy it is to configure the bridge. And I would be very happy if you would like, Vlad, if you would like, you can contact us directly, and we can schedule time to show you how it works and how it's easy to configure.
Well, Lior, thank you so much on behalf of our audience. That was just fantastic. It's really been amazing just listening and learning from your experience. As I mentioned earlier, we have 4 lucky winners for today's $100 Amazon gift card giveaway, and the winners are Carlos M, Doug F, Stan T, and Pan B. Somebody from the DevOps team will be sending you an email to confirm your email address and get the gift card over to you promptly. As I mentioned, this webinar was recorded and the slides will be available to you on demand at devops.com in a couple of hours. I will be sending you a link to the slides and recording as well. Thank you so much for spending an hour of your time with us. We truly appreciate it, and we look forward to seeing you on the next devops.com webinar. In the meantime, stay safe and be well.